Let's continue with this particular example. In this example, we said that the impulse response is the unit step, and the input is a decaying signal like this, starting from 0. And we found the output like this. I recommend I give you as an exercise this one. Okay, be careful about this. You should really try it. This is our next. You can think of it as a next example, but I'm not gonna solve it. I could solve it, but it will take too much time. That's the question is as follows. Suppose h of n of a linear and time invariant system. By the way, if I'm giving you impulse response, I shouldn't further emphasize that it's a linear and time invariant system, because if it is not linear or if it is not time invariant, then I cannot talk about an impulse response anyway. So whenever I give you an impulse response, you can just assume that it's linear and time invariant. So all these convolution stuff works. H of n is alpha to the n u of n. This is a system with this kind of an impulse response, and now the input is u of n. The input is u of n. What is the output? You can certainly say that the output is the same as the previous example here, because I just changed or interchanged their roles. I said that the impulse response is this time the second signal, and the input is u of n. Then what happens when they interchange? Y of n is equal to x of n convolution h of n is the same as h of n convolution x of n. So it's the same answer. But is it the same answer? That would be a very good exercise for you. Please do that. Please apply these inputs, u of n inputs, which are impulses one by one. To this impulse, this is the output. To this impulse, the output is one shifted towards right. To this impulse, it is one more shifted towards right. And then you add them up. As you see, it will again be alpha to the 0 plus alpha to the 1 plus alpha square plus alpha cube plus etc. as the values, which will provide you with the same, exactly the same result. But verify this by yourselves. This commutative property is a very nice property, because you will never know which one is easier to slide and add. You may find this one easier. As a matter of fact, if you do this example by yourself, you will see that this one is easier to understand than this one. This was a bit more complicated in terms of evaluating one by one the samples. So please do that. Now we will continue with the mathematical implementation of the convolution, or the geometrical implementation, in other words. Geometrical convolution. It's best for you to go to the web pages of this course, but I'm not sure where I have submitted the Java applets for this one. There are several applets available for this course. I guess it's under the department web pages, EEM 305 course dedicated web page. From there, there's a link of, or even there, they could be there. I didn't check recently. There are some Java applets. Since they are animations, they are interactive animations, it's easier to understand what graphically this geometrical convolution may mean. But it is as follows. Let's write down the formula. This is the convolution, all right? Now, over the axis of k, let's draw two things. The first thing is x of k. The second is h of n minus k. Let's think of the same example as we just erased from here. X of n was 0, 1, 2, wasn't it? It was this, right? Or was this h or x? Which one was this? This was x originally, the quiz question. I guess this was x. Or let's take it this way, and let's have h of n as 1, 1, 1 at 0, 1, and 2. Now clearly, over the k-axis, x of k will be the same shape, right? This one, and this one. 1, 2, and 3. This is the k-axis at 0, 1, and 2. This k is just an axis now. Can we draw h of n minus k? Or how can we draw it? It's the confusion that we always encounter. Do we negate the axis first and then make this much shift, or do we first shift and then negate? They are ambiguous, right? But this h of n minus k depends on a n, of course. What is this value of n? We will choose several of these things. For example, let's take it as 0. Let's have n is equal to 0. When n is equal to 0, what is the output then? X of k, h of 0 minus k is equal to, this summation, is equal to, this is equal to y of n, remember. When I take n is equal to 0, the same n is equal to 0 is here. So I say that y0 is equal to summation x of k, h of minus k. Or if I take this to be 1, if n is equal to 1, then I will find y1 then. Right? X of k, h of 1 minus k will be here. It will give me y of 1. I will find y of 2 as x of k, h of 2 minus k. So it all goes on like this. And I'll evaluate y0, y1, y2, etc. one by one now. The methodology will be like that. What is y0, for example? It is xk times h minus k summed up, added up. This is xk. What is h of minus k? I'm claiming that it is this. Do you agree? This is h of minus k. Okay, do you agree with this one? H of k was there. H of minus k is just flipped around like this. This is h of minus k. This is x of k. When I multiply these two, what is the multiplication? The multiplication is just a single impulse, because the other values are all zeros here and here. So everything is multiplied by 0, but this one and this one are multiplied. This is h of minus k, this is x of k. I multiplied them and I have this result. This is the multiplication. Do you agree? Now let's sum them up. Sum the values of this multiplication for all k's. So it is 0 plus 0 plus 0 plus 1 plus 0 plus 0 plus 0 plus 0. So what is that summation? It is the integral, it's the area, or it's the sum of this signal here, this multiplication signal for all k's. K from minus infinity to infinity, this multiplication. What is that? What is the sum of this? 1. This is 1, this is 1, they are multiplied, no other things are multiplied, they all provide you 0. So the summation is 1. Do you agree? All right. Now, h of 1 minus k, because I want to evaluate y of 1 now, not y of 0 anymore. So I need h of 1 minus k. H of 1 minus k is this. And if you do not feel comfortable about this, then you have to just put some labels. But it is 1 shifted towards right. Okay? If you don't understand, please work on it. For the time being, let's take it as this one. This is h of 1 minus k, and this is x of k. What is the multiplication of these two? 1 times 1 is 1. There's also 2 times 1 here, which gives you a 2. So this is 1, this is 2. The others are zeros, because this is multiplied by 0. This 3 is not multiplying anything. So this is 1, this is 2. And therefore, this is the multiplication of x of k and h of 1 minus k. Multiplication of x of k, h of 1 minus k. Let's sum them up for all k's. What's the summation? 3. 1 plus 2. Then let's continue. H of 2 minus k is 1 further shifted to the right. Oops, sorry. Like this. So what did we do? We flipped around this thing and start sliding it towards right, one by one. I flipped around and slide it, and then slide it again, so I get this. And the multiplication of h of 2 minus k by x of k is 1 times 1 is 1. 2 times 1 is 2. 3 times 1 is 3. And then the others are not involved. There's nothing else anyway. So if you sum them up, what's the summation for all k's? Sum them up. 1 plus 2 plus 3 is 6. Let's continue. H of 3 minus k this time. It's a pity for you that you cannot take notes of these things, because I'm erasing and drawing all over these things. H of 2 minus k is that signal, 3 items flipped around, shifted, shifted, and shifted again. So it will be these 3 points. Shifted one more towards right. And the multiplication now. 1 times 0. So we don't have anything here now, unlike the previous. 2 times 1 is 2. 3 times 1 is 3. And 0 times 1 is 0. So all the others are zeros. Like this. This is 2. This is 3. Add 1 and 2. Sum them up. The multiplication of these two signals is this. And then we sum up. What's that? 2 plus 3 is 5. Sorry, y of 4. So this time it's the previous one was already h of 3 minus k. Sorry about that. This is y of 4 minus k now we have to do. So I'm erasing from here and I'm plotting here, shifted towards right. And the multiplication is only 3 times 1 is 3. These two will be multiplied by zeros, and these two will be multiplied by zeros, so we don't have anything. 3 times 1 is 3, and the summation is 3. If this goes further to the right, what is the multiplication? 0. We have no associating points, so y of 5 is equal to 0, you can say. As a matter of fact, you could go in the other way, in the other direction. We said that h of minus k is this. Right? Flipped around version of h of k. H of k was here. We flipped around. This is h of minus k. What is h of minus 1 minus k? That's also possible. H of minus 1 minus k is this, shifted to the left. This one. And if you multiply h of minus 1 minus k, this one, with x of k, there's no multiplication. That's why I didn't evaluate y of minus 1. There is no y of minus 1. Y of minus 1 is 0, in other words. Notice that if this thing had some negative indices towards left, then by flipping it around, I should start from more negative indexes such that it overlaps with this one. I'll try to give you an example regarding that. But for this example, y of minus 1 is 0. Y of minus 2 is further to the left, therefore it's all zeros. There are only such non-zero terms, y of 0, y of 1, y of 2, y of 3, and y of 4. And these are the values. And how did we do that? We did it by flipping around the second convolution item, which is, for this case, h. We flipped around h and slide it to the left and to the right. To the left will correspond to indexes of the output of y of minus 1, minus 2, etc. To the right, y of 0, y of 1, y of 2, y of 3, etc. So we flipped around and slide, and meanwhile, this flipped around and slided h of n minus k here is multiplied by x of k. And this multiplication is then accumulated. We put a summation for all k's. And the result will correspond to the output value at the corresponding shift amount. If the shift amount is 1, it will give you y of 1. If the shift amount is 2, it will give you y of 2. This flipping around and sliding convolution is the geometrical or graphical way of performing convolution. And people just remember this convolution method more than the meaning of it. What was the meaning of it? It was the response to linear and time invariant systems. Soon you will forget that the convolution corresponds to something like that, the LTI system response, which was here. Within a few years, probably you will only remember how to make convolution, which is this. You flip around and slide and multiply them, and then sum them as a result of the multiplication. As you see, I'm erasing, drawing new things over and over again, but please find those Java applets from your web browser. Make sure that your browser is Java enabled. Over there, using your mouse or pen, whichever input style you may use, you draw two things, two signals. One of them will correspond to x of n, the other one will correspond to h of n. The Java applet automatically flips around one of them, and by dragging with the mouse, it slides. Okay, you hold it and it slides to the left and to the right. And the amount of overlapped summation is simultaneously live shown on the same page. So this multiplication result is spontaneously changing, simultaneously changing as you drag the above thing, this one for example, you slide this one. And the result is just the summation of those items. That summation is also drawn, plotted over there. So the convolution result is here. You draw the first signal, you draw the second signal with your mouse, and then you just slide them and you see how the convolution works. You should do that. You should go to the computer and try to make convolutions. But while doing that, although it's like a game, just playing around with the graphics, I recommend that before drawing your signal shapes, try to anticipate, try to guess what the convolution output will look like. Because after some time, the convolution result will be, if it is well understood by you, if you understand the convolution concept very well, you will start estimating what the output of the convolution would look like. For example, this is x of n. And this is h of n. By the way, for the Java applet, there are no labels. Okay, it's just the magnitudes that you draw, and there's no label of 1, 1.5, 2, or anything. But for us, let's have some labels. If x of n is like this and h of n is like this, after some time, if you work enough on that Java applet, you will immediately be able to draw the output without further analysis, without any computations or anything. And how does it work? Let's flip this one around and then sliding to the left and to the right. If you go to the left, it will not overlap with this x. So the multiplication will be nothing. We must start from 0 and we must slide towards right. After some time, if you slide too much towards right, it will start non-overlapping again. But how many times will you overlap? This is the first flipping around, and this is the first overlapping. One item is overlapping the other item from x of n. So this is h of, let's call this x of k, this is then h of minus k. Flipped around. And the output is the multiplication of 1 and 1, sum up, it is 1. Y of 1. H of 1 minus k is this, shifted towards right. Two items will overlap, okay? And 1 times 1 is 1, 1 times 1 is 1. There will be 1 and 1. If you add them, it will be 2. So this is 1. This is 2. Y of 2 is how many items overlap? 3 items. Their multiplications are 1, 1, and 1. The summation is 3. 3 minus k is this. They completely overlap, right? And the multiplications are 1, 1, 1, 1, and their summation is 4. H of 4 minus k, what is that? It's this. Shifted towards right. Now, this time these three items are overlapping these three items. They are multiplied one by one, and the multiplications are 1, 1, 1. There are only three of them. The summation is 3. H of 5 minus k will be this, and we will find y of 5. What is that? We have only two overlaps, and multiplications are 1 for each. Summation is 2. Y of 5 is 2. H of 6 minus k is this, and there is only one overlapping item, and y of 6 is 1. If you go further towards right, then y of 7 will be 0, because the shifted versions and this one will not overlap with each other. So you will have nothing. Now, as you see, it is first increasing to a maximum and then decreasing. Visually, when you have two of the same rectangular box shapes as the first signal and the second one, when you flip one around and start sliding, it will linearly increase until everything matches, and then it will linearly decrease. It will start to decrease. So it will be 1, 2, 3, 4, and then 3, 2, 1. Increase and decrease, which forms a triangular shape. Suppose that one of those box shapes is longer than the other one. For example, x of n is again these 4 impulses with all ones, and h of n is 6 of these things. 1, 2, 3, 4, 5, 6. From 0, 1, 2, 3, 4, 5. So can you guess what the convolution will look like? Yeah, that's the name, trapezoid, I guess, in English. When you flip this one around, by the way, be careful that you could flip the other one around and slide as well, because it doesn't matter which one you're convoluting with. Okay, you can interchange their places. This is the same thing. So let's flip this one around and start sliding. For the first one, it will be 1, and then 2, and then 3, and then 4. And then for 2 more sequences, it will stay as 4, and then it will start decreasing, 3, 2, 1. The amount of overlap will decrease. Okay? So it will be, as your friend has suggested, first increasing and then staying constant and then decreasing, sort of a shape. All right? How about these? X of n is again the same. Let me insist on this. And h of n is this. 1, 1, minus 1, minus 1. When you convolve, what happens? Do you have any intuition about what's going on? If you flip this one around, it will be 1 and 2. 1, slide more, and it will be 2. But then if you shift one more towards right, this time a negative entity will get in, so it will come back to 1. And if you slide even further, these two and these two will be positives and negatives multiplying. So the net result will be 1 plus 1 minus 1 minus 1, which is 0. If you slide further, it will be a negative 1. And if you slide further, it will be a negative 2. If you slide further, it will be again a negative 1 and then a 0. But you should try that. And don't always draw any kind of shapes and try to observe the outputs, because it's very important for you to develop some intuition about what the convolution result will look like. Okay? And that's how the convolution works. Now, I have, well, it's erased. There was this example of infinite extent convolution. Those infinite extent convolutions, unfortunately, the Java applet will not let you do that because it's a finite drawing tool. But can you find the convolution of these two using this graphical or geometrical methodology, which is this? Again, x of n is equal to u of n, h of n is equal to alpha to the n u of n. Now what? Does it work the same way? Is this intuition valid? The answer is yes, it is valid. This alpha to the n u of n was this decaying exponential. We remember that, right? This was alpha to the n u of n. Let's flip it around. And let's multiply it with our input signal, which is u of n. This is u of n. This is h of minus n, sort of thing, flipped around. This is 1, this is 1. The output at y of n at n is equal to 0, the amount of shift is 0, is 1 times 1, 1. Let's shift this thing to the right. What is y of 1? So y of 0 is equal to 1. What is y of 1? It will be 1 plus alpha, right? 1 will be multiplying this, and alpha will come in from here. What is y2? It will be 1 plus alpha square. Just go on. Isn't it the same formula that we developed as the answer to the question? Okay, it's the same. And it also works in the other way around. If you flip around this u of n, it will also accumulate 1 plus alpha, 1 plus alpha square, 1 plus alpha square plus alpha cube, etc. So it doesn't matter which one you flip around. You flip around one of them, and you slide. The amount of slide will give you the index of the output. Okay? That's how you make convolution in discrete time, of course. And in order to better understand it, I strongly recommend that you go to the Java applets today, probably. So let's stop at this point.